Okay, so in this video I'd like to give a short demo and tutorial on how to use something called the Matlab Engine library of Matlab, and that's sort of kind of an aside for now. I want to give a high-level overview of what I'm trying to do first by giving a demo. So as you can see, I'm about to call a C application that I've already written and compiled. And what that's going to do is it's going to kind of start, it's going to of course call the Matlab Engine API at some point, but it's going to do a simple task which I could effectively also do if I wanted to, just by using regular Matlab code, which is going to be interpreted by the Matlab interpreter as long as I follow regular Matlab syntax. But I'm not going to do that. What I want to do specifically is I prefer to use the C application to first do stuff in C before calling Matlab. So I can have my C application, which has its lifetime, and it will maybe open a Matlab as a process, and then I can continue to do stuff in C if I wanted to, but I could have Matlab open on the side where perhaps I only want to use Matlab for plotting or for its various visualization functionalities, its graphics libraries, etc. So here I'm just going to run the demo, and hopefully you can get a picture in your mind as to the motivation. So here, I happen to be calling a C application. It opens Matlab as a process, and it simply plots this position versus time graph. So something as simple as that. I'm trying to give a tutorial on how to do that, and just maybe give some insight into why it might be useful. As you can imagine, like Matlab is itself is kind of limited in terms of how fast it can actually execute some instructions, and so sometimes you're at a trade-off where you might much prefer to write an application in C or C++ so you can get that speed side of the trade-off, where you only want to call Matlab in order to do certain functions such as plotting, which would be a lot less trivial to write your own plotting stuff in C. So hopefully now that the motivation is more clear as to what this tutorial is about, and so let's get right into it. So the first thing that I really want to point out is that I haven't done anything fancy here. I've used the engdemo.c sample code as what I'm going to be interested in compiling. So what that includes, first of all, is this engine.h header file. So as you can see over here, I have two files set up. I could just as well put all of it into one, but I just have chosen to put it into two. And one of the first things that's to point out that I've included is this engine.h, and I happen to copy, their includes their other include items, which are the stdio and stdlib header files. But beyond that, the first half of this source code that I have on the right, which is my source code, so maybe I'll bring that source code to the left and then bring this sample code to the right. The source code here on the left is simply copied exactly from the first half of the source code here on the right. And I've just copied the bottom half. Like, I've skipped over a bunch of stuff, and I've just copied over some stuff for cleaning up some of the objects. And so what does this first half of the sample code actually do? Is, as you can imagine, it does what I've kind of demoed at the beginning, is that it calls it creates this engine data type here, which you get a pointer to it. And to actually create it, you have to call this engopen function that you get by including the most likely the engine.h, or I think this function is well defined enough that you can call it. And then So once you call it, you just need to use people who use mechs would be familiar with this, but for now, maybe that's just an item to keep in the back of your head of something that you could research on your own, is how to follow the MATLAB suggested syntax and for defining its own data type of its own matrix data type, and how to get a pointer to it, and then how to call mx create double matrix that would allocate the memory required to create that type of object. And then the next thing you would have to do is call memcopy. I don't think you can get around this part. So the memcopy would, you kind of need to call memcopy, or you might have a different way, for example, but you essentially need a data, you need your pointer t, which is a pointer to type mx array. You need to populate it with the data, so you call memcopy in order to do that. I think this is the destination buffer of memcopy, this first argument, and then you then take that object which has the data, the mx array, you specify its pointer to the eng put variable function, and you also specify the engine pointer, and this is the name that it will be populated as in your MATLAB workspace. So you're just going to use the same name. It's kind of a vague name, but you're just going to, if you've used MATLAB before, you can imagine and you understand that you have a list of workspace variables, so it's going to appear under your workspace with this name. So thereby, and you actually make another variable called d. So you make two variables, t and d, and then you will simply be set to go after this point. And notice that this is a well, actually, you define d. You don't have to pass it in. You define it as MATLAB code, and you don't really have to do this memcopy as you did with t. So hopefully, it's a little bit. I don't have to go into details about why that's the case, but essentially by this point you have two variables, t and d, and you're able to plot them. And so you notice this eng eval string function is sufficient to pass commands, like essentially pass strings and issue commands to MATLAB line by line, and we basically are. This idea is kind of powerful, and it should extend to just beyond just making a simple 20-second call to like plot some kind of simple data like position versus time. So, and the last thing that I end up doing is just making it actually stay alive for 20 seconds. So I specify pause and then open bracket 20. Just to do that, and then again clean up that just to be good, just to have good programming practice. You want to call the correct close functions on these objects, these pointers to their respective objects, and that's the end of the program. So hopefully we're doing okay on time so far. I'll just quickly show the make file that I'm using to compile this. What needs to be specified is the paths to the correct libraries get specified via this part of the argument list. And again, I'm using G++. I'm using GCC compiler for C++. I'm using MATLAB under this MATLAB home variable name location that I've specified. And so that is with respect to MATLAB home. And I then need to specify first one of two things is the libraries that I want to link against, and this minus else, which will tell the linker the directory, simply just the directory that it should search for whatever libraries I then follow up by specifying that I need linked into my application, or in a shared way, either statically or dynamically. Yeah, so that's the reason that I specify those arguments to the argument list for the link step. And then for the compile step, it's simply, I think, specifying the include directory. So I need to specify for the compiler to search within this directory with respect to MATLAB home. So the extern include, and it'll find whatever nice header files that it needs to actually make sure everything's, you know, defined acceptably. And so the flags are not that critical. If you're, I mean, they might be, but if you're just trying to get a quick demo, like a quick test to convince yourself that this works, and you want to use some of my sample code here, I don't mind at all. So hopefully that is sort of a lot more clear at this point. And then if that's the case, then we can then try running this. But before we do that, I'll just make two more items, go over two more items that I think I had on my checklist. Is that you saw the thing working, of course, so that's not going to be a surprise. But if I open another, if I just to cover those two items, if I just open another tab, and then so I can just do an ls to show what I have in there that corresponds to what I have in here. And what I'm interested in doing is I'm interested in making it again, just to show that it compiles. So what I currently have defined in my source code, it compiles accordingly. So that's not an issue, I don't think. But the issue that I want to go over is that if I try to now run this, so I can first chmod to show that to make it executable, and then I want to demonstrate that you might come up with this error if you're running the same distribution of Linux that I am, or other similar distributions. They depend upon first one of two things. So the loader needs to know where. The loader also needs to know where to search for some of these objects, which are not objects, but these these libraries, which are shared libraries, and they're not, so therefore they're not statically or linked in. They're dynamically linked. So the loader needs to know where those reside. And so in order to do that, you need to specify something like, if you first want to check how this is defined in your new terminal or your new environment, you can type in echo, and currently it's not defined at all, it's not populated. If you then do what I do here, which is to export this in the way that I am, this will append to something which is empty with the extra stuff, which is this this entire file path to the, or folder path to this 64-bit Linux folder, which has basically, I think, the libraries that you need, the dynamic ones that I mentioned. So now when you echo it, it can find those, but let's try again now. Okay, so I think it will work once I hit enter on this. Lastly, I just want to show that another reason that it could possibly choke at that last step is if you don't have certain packages installed on your system. So those for me were actually these two packages, or one of the two, C shell and TC shell. And once I installed those, that was the final thing that actually made me able to run this demo successfully. So I think that covers everything. If I seemed like I was in a rush, it was just to try to make this video not go over like 10 minutes, like I might have tried a few times, to be honest. And the first couple times I did alright, then the second time it went way over time, so I'm interested to see how many minutes this demo and tutorial has taken in total. So yeah, thank you, and hopefully that'll be helpful to anyone who's happens to be watching this video.